All right, picture this. You're in the final round for that senior platform engineer job. You've gotten through all the technical questions, the easy stuff is over. Now comes the real test. A live fire scenario where they want to see how you handle the heat. This isn't about what commands you've memorized. It's about proving you have the judgment to save the day when everything is, well, on fire.
The interviewer leans in. Okay, PagerDuty is screaming. Our main service is completely offline. You have shell access to the cluster. Walk me through it. This is it. This is that moment. The one that separates the senior folks from everyone else. The clock is ticking. So, what's the first thing you do?
Okay, let's break this down. They've handed you the most important clue right up front. Crash loop backoff. Now, what does that really mean? It means a container is trying to start, it's immediately crashing, and Kubernetes, being the helpful system it is trying to restart it again and again and again. This is our ground zero. This is where the investigation begins.
Now, my first instinct, and your first instinct, should never be to panic. Don't start changing things randomly. The very first step is to gather data. You have to be systematic. Think of yourself as a detective arriving at a crime scene. Your goal is to understand the blast radius and come up with a theory. We have to triage the pod itself before we even think about the rest of the system. Calm and methodical wins the race. For anyone who lives and breathes Kubernetes, this is just pure muscle memory. It's a three-step dance. First, kubectl get pod. This just confirms what we already know, and importantly, shows us the restart count. If that number is high, yep, it's a crash loop. Second, kubectl describe pod. This command is an absolute goldmine. We're hunting for clues in the events section. And third, kubectl logs -previous. That little -previous flag, that is the magic key. It lets us see the logs from the container's very last run, right before it died.
So in that describe output, you're going to see something called an exit code. Think of it as the container's last words. You'll see some common ones here. For example, if you see a 137, that's the container screaming, I ran out of memory. But in our scenario, the exit code is 1. That's a bit more generic. It's just the application saying, hey, something inside me went wrong, an unhandled error. And this is exactly why we check those previous logs. Bam! There it is, clear as day, ECONNREFUSED. What does this mean? It means our payment service is trying to talk to a Redis cache when it starts up, and the connection is being flat out refused. This is the smoking gun. This is the moment our whole investigation pivots, because we now know the problem isn't with our application, the problem is with something it depends on. Now, here's a key distinction. A more junior engineer might get stuck here, trying to debug the payment service code itself, but a senior engineer knows to immediately pivot. That error message is a giant flashing arrow pointing us to our next target, the Redis service. We have to widen our search from just one broken pod to the health of its dependencies. So we run kubectl get pods in the cache namespace, and we see something new. The Redis pod is just stuck. It's in a pending state. A pod gets stuck in pending when Kubernetes says, yep, I see you, but it can't actually find a place to run it. Why would that happen? Well, the scribe on this pod will tell us. It's usually a resource issue, like not enough CPU or a problem with storage. And there it is, the root of all our problems. The events for the Redis pod tell us its request for storage, its persistent volume claim, can't be fulfilled. A quick kubectl get storage class confirms our worst fear. The storage class it needs is just gone. Someone probably deleted it by mistake, and that's the whole domino effect right there. No storage class means no new storage. No storage, no Redis. No Redis, no payment service. We found it. We know the why. Now it's go time. In a real outage, our job is to restore service as quickly and safely as possible. We're not writing a big report right now. We are laser focused on getting that payment service back online. So let's build the recovery plan. Here's our 3-step playbook. Step 1, we have to bring back that missing storage class. We've got its definition in our infrastructure as code repo, so we'll kubectl apply that YAML file immediately. Step 2, Kubernetes won't automatically fix the old storage request, so we need to give it a little nudge. We'll delete the pending Redis pod. Now, that sounds scary, but its controller will immediately try to recreate it. This new pod makes a fresh storage request, and this time it'll succeed. Step 3, we watch. We monitor the Redis pod till it's running, and then we watch our payment service pods come back to life all on their own. Now, in an interview, this is a great place to show some strategic thinking. Someone might ask, why not just roll back the payment service? And that's a fair question. But a rollback wouldn't have helped because the payment service wasn't the broken part. We had to fix forward by addressing the root cause in the infrastructure. Explaining this choice shows you're not just running commands, you're thinking strategically about the fastest, most effective path to recovery.
Okay, deep breath. The outage is over, but the interview is not. Fixing the problem is only half the battle. Now you have to communicate what you did, why you did it, and most importantly, how you're going to stop it from ever happening again. This is where you really get to shine.
And the absolute best way to structure your answer is using the STAR method. It stands for situation, task, action, and result. It's a super clean, professional framework that turns the chaos of an incident into a clear, compelling story of your competence. It shows the interviewer you have a structured mind, even when the pressure is on. So let's just apply it to our scenario. Situation: the payment service was in a crash loop backoff because a critical dependency was failing. Task: my job was to diagnose the root cause and restore the service as quickly as possible. Action: I traced the error from the pod logs to a dependency, discovered a missing storage class, and then recreated it to unblock storage provisioning. Result: service was fully restored in under 15 minutes with zero data loss. See how clean that is? It's the perfect executive summary. But we don't stop there. This is the final, most important step, the one that really shows a senior SRE mindset. You have to talk about prevention. I'd recommend 3 things. First, let's add a new alert so we get notified immediately if any storage claim gets stuck in pending. Second, let's harden the cluster with an admission controller to prevent anyone from accidentally deleting critical resources like a storage class. And third, let's make the payment service itself more robust with a startup probe so it properly checks its dependencies before starting, which would prevent the crash loop entirely. And that is how you ace the production outage question. You show a calm, systematic process. You diagnose the true root cause across the entire system, and you finish with a forward-looking plan that makes everything more resilient. Because as a senior engineer, your real value isn't just in firefighting, it's in fire prevention.